Hi guys, we are starting our measurement unit. So we're going to first talk about one-dimensional measurement, which would be finding perimeter or using any sort of length. So I gave you a little list here of one-dimensional. What does that mean? If you use the word units, inches, meters, basically anything you can measure with a tape measure. The first example is fairly straightforward. It gives you a trapezoid. We want to find the perimeter of the shape. Well, they already gave you 3 sides. This is 17, 8, and 11. The strategy is, for this, break it up. To find this fourth side, I can force it into a triangle. So I dropped an altitude. So I went from this vertex to the opposite side, put in some right angles, and then I have a rectangle. So if this is 8, that's 8. If this is 11, that's 11. Therefore, from 17, this must be 6. I notice I have a right triangle, 2 sides, pop into the Pythagorean theorem, and AD is 10. They're even trying to lead you through that with that strategy for part A there. Then it says determine the perimeter. So add up all the sides, and it's 46 feet. So notice there's no squared, no cubes. It's one-dimensional. So bumping up a little bit, we're going to get money into the situation. So you're building a fence. Math problems love fencing. I don't know why. I don't really fence much in my life, but it's all good. So you're building this fence. It costs you 75 cents per linear, okay, just a line, segment, whatever, foot. How much will it cost to enclose the entire trapezoid? So couple approaches here. Some students intuitively know if I have 46 feet and it costs this much per 1 foot, I should multiply them. Fine, multiply them. You'll get $34.50. Another school of thought is to do this unit analysis. And this is kind of cool once things get more complicated. So what I did here is I said 75 cents or $0.75 per, means divide, feet. So for every 1 foot, this is how much it costs you. Then if you multiply by 46 feet, what happens is the same unit divided by itself reduces to make 1, and you're definitely left with money. So more to come on that kind of analysis, but I wanted to give you a little brief intro there. The next sort of problem involves coordinates. You guys are very good at this. I graph the figure. It happens to be a parallelogram. And we want to find the perimeter now. So as you know, we've done this pretty much all year. If anything is horizontal or vertical, so in this case, these are both horizontal, I can simply count the units. So both of these are each 7 units. Makes sense. Opposite sides should be equal. Once I throw a diagonal into it, that's where I'd have to put the right triangle around each piece. So you could do 2 or just 1 because you realize the opposite sides are congruent. And work with the Pythagorean theorem again. Super popular. So I ended up getting 116. Through a little bit of exploration, I realized 4 is the biggest perfect square that divides into 116. It divides in 29 times. The square root of 4 is 2. So both of these sides have a length of 2 square root 29. I wrote out my perimeter, all the sides that I was going to add. And then you can kind of think of this as like terms. The numbers without the square roots, without the radicals, I can just add. So that gets you to 14. And then I just treat these as if it was 2x plus 2x. The x would stay the same, but you'd have 4 of those. So in this case, you have 2 times square root of 29, another 2 of those square roots of 29. So add the numbers in front of the square root, leave the square root alone. If we go to the back of the sheet now, still working with ideas we know. We're going to involve a little bit of trigonometry here and again, talk about money. So now you are making a wooden frame. It costs you $1.25 per linear foot. So you're thinking one-dimensional segment. I can measure that. The frame is in the shape of a right triangle, gives you the hypotenuse, and it gives you an angle. I need the overall cost. So technically, I want to frame this. I need the perimeter, so I need the side lengths first. Rounding here, I would go out a few places. So you notice my final answer here, I went out a few places. But I rounded the nearest tenth over here. We can kind of play around with that. I'm not too much of a stickler on that here. What I did notice was I have this acute angle. I only had one side, so I need to use trigonometry. I decided to go after this opposite side first. So having the opposite side and the hypotenuse, I could use sine. So sine of 32 equals x over 12. Multiply the 12 with the sine of 32. Or if you need to put this over 1 and cross multiply, you'd still get the same effect. So it was about 6.4. From this point, I could have done the Pythagorean theorem. I chose to use trigonometry again, though, to find this adjacent side. So now that I have the adjacent side and the hypotenuse, I chose to use cosine. So cosine of 32 equals y, which I don't know, the adjacent side over the hypotenuse of 12. Again, I multiply these together, either because you put it over 1 and cross multiplied, or you know to multiply each side by 12. You get 10.2. I added all the sides together, and I again used that analysis. I said, okay, it's $1.25 per, so divided by feet, times 28.6 feet. The feet cancel out. I definitely know I'm doing the right operation. Basically, it's either multiplication or division, but this guarantees I feel good. It's $35.75. Makes sense. I can go buy that now, kind of move on with my life. So the next thing, totally new, gotta take your time looking at this, regular polygons. So if a polygon is regular, it just means all sides are congruent and all interior angles are congruent. We've already talked about two very popular regular polygons this year. One would be the equilateral triangle. All the sides are equal, and therefore all the angles are equal. And I even wrote you a little note, all the angles are 60 degrees. And the square, that's our regular quadrilateral. All the sides are equal. All the angles are equal. They all equal 90. I also gave you some pictures of the next few polygons. So we have a pentagon. It has 5 sides. All the sides are equal. All the angles are equal. They're each 108. I don't need you to know that, but you could figure it out. I can show you that if you want to know more. Hexagon has 6 sides. Heptagon, 7. Octagon, 8. A nonagon, 9. And a decagon, 10. Below is the kind of problem that kind of pulls a couple of these ideas together, and it's a good one. They're going to give you a regular polygon of some sort. Here they're giving you a regular pentagon. So 5 sides, all 5 sides are equal. And we're drawing from the center. You can kind of think of it as the center of a circle. If you put a circle perfectly around this, if you circumscribe that. So the center of the circle, the center of the figure, and we're drawing technically these radii. So we're just connecting the center to each vertex of that shape. So now you have 5 congruent triangles. I want to end up figuring out how to find the perimeter of the shape. But first, I need to work from the inside out. So it says find the measure of ACB without trig. To be honest, I don't even know how you would use trig here. Think of it like this. These are all central angles. And we know if we go around in the circle, it adds to 360. So I just focus on these angles here. I don't care about these outer angles. They don't bother me. So I did 360 divided by 5. Each was 72. And then they're even showing you an altitude here. Okay? You're connecting at the midpoint. In this case, because it's isosceles triangle, ACD, when you connect at the midpoint here, you have 2 congruent triangles by side, side, side. These angles have got to be congruent. They're right next to each other on a line. They must be 90. Anyway, I think that makes sense intuitively just looking at the picture. So we know we can take that 72, split it in half. So each of these angles is 36. So ACB, 36. On your packet, it says nearest thousandth, which is 3 places. So ignore this, pretend it's not there. Discuss exact form. So it says now I want to find A to B. So I look at A to B. I chose to redraw my triangle over here Okay, it's a little bit simpler to look at, and put in the variable I want to find. Put a variable in for the side I want to find. Again, once you have a right triangle and you have an acute angle, a lot of times that kind of leads you down that trigonometry path. This one happened to be sine. So sine of 36 equals the opposite side of x over the hypotenuse of 5. I multiplied those together, and with some rounding, it ended up being 2.939. So that is A to B. So lastly, I want the perimeter to the nearest tenth. So don't round until the end. Don't round this yet. I chose to take this, and I doubled it. So now I know A to D. So A to D is 5.878. Then, because it's a regular pentagon, all the sides are equal. So I took that 5.878, multiplied it by 5, and then rounded to the nearest tenth, 29.4. If they give you some units, throw them in there, so inches. One last thought, and I'll let you guys go. You could have also said, well, I know half of one side is 2.939, so there's 10 halves around the figure. So you could have also said this times 10. Where does it get you? 29.4. Please let me know if you have any questions.